Greetings, traveler. I'm the Calculus Cleric, and today we're working with the convergence of improper integrals. So, the specific problem is to determine whether the improper integral converges, and if so, evaluate it. So, here we have the integral from 1 to 0 of ln x d of x. And so, what we're going to do with this is we're going to see whether it converges or not. But first, we have to determine how does this become improper? Because normally when we have improper integrals, there's an infinity sign or a negative infinity sign somewhere in that integral. But this doesn't have it, so it requires one extra step. Basically, we get these two bounds and we just stick them into the function. And if the answer comes out, great, then that's not the side that's improper. But if the answer is indeterminate, then that is the side that is proper, and that's what we're taking the limit of. So we take ln of 1, the natural log of 1, which is equal to 0. So that has an answer that exists. And then we take the natural log of 0, and that's undefined. So it doesn't actually come out to anything, which means that we're going to be taking the limit as r approaches 0, because we're going to replace that 0 with r and say limit as r approaches 0, and that's how we evaluate improper integrals. But we also have to stick a sign at our r's, so there's either positive or negative. It's positive when it's on the bottom, it's negative when it's on the top. So if I took the limit of 1, then it would be 1 negative. But since we're taking 0 and that's on the bottom, it's going to be 0 positive. And then to solve this, we're going to use integration by parts. So we're going to get a u value, we're going to get a v prime value, and we're going to find the u prime value and also the v value. So for our u, well, we're probably going to use ln of x, because there's nothing else really there that we can take as our u value. Now, in the strange case that there is nothing there, well, everything is multiplied. You can multiply everything by 1, so there's a secret invisible 1 in front of everything. So that's going to be our v prime. And obviously, we wouldn't use ln x as our v prime because we can't find the antiderivative of that, which is why we're even doing integration by parts in the first place. So now we find the derivative of, don't forget the dx there, and we find the derivative of ln x, which is 1 over x. And then we also find the antiderivative of 1, which is just x. And so the formula for integration of parts, let me first write out the limit, is going to be u multiplied by v negative the antiderivative of u prime multiplied by v. Let's not forget our bounds though. So 1 and r. So u prime 1 over x multiplied by v, which is x. So these will conveniently cancel out and give us 1. And then from here, what we're going to do is evaluate the integral first. Ln x, 1r, negative. The antiderivative of 1 is just x. So just like that. And then now we just plug in the bounds. So we plug in 1 and we plug in the r's. Plus r. Because it should be negative, but negative multiplied by negative sign is positive because there's that negative sign over there. Now we're basically going to replace all the r's with zeros because we're taking the limit as r approaches 0. In this case, that's what we do. So 1, okay, ln of 1, that's 0. Anything multiplied by 0 is just 0. So that's 0 minus 0 ln 0. Darn it. Okay, we'll worry about that later. And then negative 1, oh, that stays as negative 1. And then plus r, that will just be 0. Okay, so 0 ln of 0. So basically, we have a undefined term right here, which makes this whole thing undefined, which means we can't do this because this is illegal. Darn. So what can we do? Well, when we take limits and they don't really work out, we use something called L'Hopital's to make it go from undefined to not undefined. And so we're going to need to make it so top and bottom are both indeterminate, so they have no answer. And a common trick is to do it like this, because ln of r, we know that ln of 0 doesn't come out to anything. r does come out to 0, but if we do 1 over r, then this whole bottom part, then this should get us a 1 over 0, which is indeterminate form. So then we can take the L'Hopital's of this, which is basically where we just take the derivative of the top and bottom. So the derivative of ln of r is just 1 over r. The derivative of 1 over r, well, 1 over r is the same thing as r to the negative 1. So that's negative r to the negative 2, which, when you write it out, is just this. Because negative r to the negative 2 is that, and then we just do fraction division to get this, which gives us, so the r's will cancel out. So that just leaves us with negative r. But as r approaches 0, we just plug in 0 here. Negative 0, well, that's just equal to 0. So r of ln r is just 0. So for our final answer, 0, negative 1 plus 0, well, the only value that will remain is negative 1. And that is the final answer. So that means this improper integral converges to negative 1.